This is attempt number
7. We've tried to record this thing 7 times. 7.
Now let's hope that this wonderful computer that the school is so generously giving
Brand new one too, by the way.
works correctly this time around.
Oh, jeez.
I love technology.
All right.
Okay, so we are looking at some chemical and physical changes, like the song. Changes.
Yeah, exactly like that song.
They got nothing, I'm sure.
No, they don't know this.
Okay, so let's take a quick field trip down to the lab and see what Mr. Johnson has to say about some physical chemical changes.
Ordinary piece of paper. Now, what you can do is physical changes. You can rip the piece of paper, keep ripping it to a million little pieces, and what you have is just smaller pieces of paper. Nothing's changed. It's all the same. Now, the only thing that's changed is the fact that we have little pieces of paper. It's still paper. Nothing's changed chemically. So if I was to get it back to this sheet of paper like this, all I'd have to do is start putting some of these pieces together, taking some tape here, and just start arranging in order. And then voila, another piece of tape, and it's back to the original piece of paper.
Ooh, ooh. We're going to show you another physical change. We're going to go paint the rock. Changing color is a physical change.
Okay. This is something I always wanted to do. I never got to paint the rock. Then again,
nice cold night for it.
It is a we couldn't have got any colder out here.
Wait, you guys, I think somebody's out there.
Wait, who's that?
I don't know.
Wait, hey, who is that?
Somebody's out there.
Who is
I don't know who that is.
Who's painting the rock before us? Who beat us to it? Hey, you! Who are you? Gamble Rock.
Gamble.
Mr. Gamble? Gamble? What's up? Beat us to it. Physical change. Nice.
Bam! Wow, that Mr. Johnson, he's awful strong to be able to rip that paper the way he did.
And smart to put it back together.
So, physical changes are those which can be undone, and we're not creating any new substances.
Okay, so like the paper, he took the paper, he ripped it up. It was still paper, it's just smaller pieces of paper. Still chemically is paper.
Okay. And then, when the old retired Mr. Gamble jumped in and helped us, and we went out there to paint the rock, and he was already doing it for us, that would be example of another physical change.
Yeah,
Okay?
it was just the rock with paint on top of it. There's no mixing of the two. It's just a rock with paint coating it.
Yep.
And I imagine the rock is probably only like
The size
this
of a pebble?
big, maybe, with paint
It's like 6,000 years old on it.
forever on top of it.
Yes, I would agree. All right, so you got the thought of what a physical change is. Now we're going to jump back down to the lab and see what we can learn about chemical changes.
I'm recording.
Okay. Chemical change. Magnesium strap. Ta-da.
Don't look into the light.
Good? Mm-hmm. I'll just let it go, I guess. Good cow.
Big strip of paper.
I know. Could I have gotten any larger of a piece?
Let's just hope that smoke doesn't do anything.
Oh, shoot. I didn't even think about that.
You can't, I don't, there you go. That's how
I like a blood burn.
If the fire alarm is up, everybody run your
All right, now, going back to physical change, we got the piece of paper we actually retaped. I'm going to re-rip it. Again, still paper. Now, we were going to show you chemical change by burning the piece of paper, but since the fire department just left, we're going to dissolve it in acid. So I take the piece of paper, put in some acid.
Look at that bubble.
Bubble, bubble, toil and trouble. Okay, now as you keep mixing, you'll see the paper is completely disintegrated. Now this may look like ordinary water, but I would not drink it. Safety first.
Whoa! Those chemical changes. They're quite exciting.
Yeah, really exciting. Chemical changes typically are a little bit more exciting, like things like fireworks are a chemical change. So they're kind of more exciting, in my opinion.
Yes. And the question I'm sure you all were wondering, that fire alarm was not staged.
No,
It actually did go off.
just like that.
And we actually got in trouble with the fire department.
Yeah, they asked us if we knew our lab safety.
And I was clearly wearing my chemical safety goggles, so I'm not sure why they were so uptight about it.
Yeah, relax.
So, anyway. So, things that can create a new substance are what we call chemical changes. So, when I burn the magnesium strip, we ended up burning and creating water and carbon dioxide. When Mr. Johnson dipped his paper into hydrochloric acid, we no longer had hydrochloric acid in paper. We now had a new substance.
Ooh.
Okay, very good. So, how do you know that it's a chemical change? Well, we got a couple examples of some evidence.
A lot of times, or every time you see energy given off, that usually tips you in the direction of a chemical change. But you have to remember that energy is not electrical solely. It also means heat. If heat's generated, that's a type of energy. Sound is generated. Put two things together, they make like a pop or a sizzle or something like that. That is going to be a change in energy. And then also light. If you put two things together and light is given off, that is going to be an example of a change in energy.
So, like fireworks, when they explode, and they make that
Yeah.
boom and light.
Heat too, yeah, because it could burn you. Heat, light, and sound all come in fireworks. That's one big example of chemical change.
Okay. Other way is you can do the formation of a gas, and probably the most common example that you would remember maybe would be when you were like in maybe 6th grade, maybe even younger, who knows?
Yeah.
When you built that paper mache.
Those generic cone volcanoes,
Yeah.
straight up.
Yeah. So, and you added your baking soda with your vinegar, and then. Okay. Just like that, actually, with those sound effects. That was a chemical change because you were making gas, and do you know what gas you were making?
I think it's carbon dioxide. Pretty
Good call, not methane.
sure. No, yeah.
Okay.
Another one would be a formation of a precipitate. This would be like if you put two liquids together and you got like a solid that formed, or you put two clear liquids together and you got cloudiness. That's telling you that that solid that's formed is a new substance because it's not part of the clear substance number one or clear substance number two. It's something completely new and different. That tells you that there obviously was some chemical change that happened. You formed a new substance.
And then another chemical change for some evidence would be color change. Now, I'm not talking like when Mr. Gamble painted the rock. That's not the type of chemical change. We're talking about like when iron rusts. Okay, so if you have a nail outside and it gets wet and then it rusts, it's no longer that silverish, whatever color,
what,
nickel-like.
Some of you kids might be getting rusty cars
Yes,
for your
because
16th birthday.
Yeah, exactly. So that's when you have iron meeting the air and iron oxide. So that's what's the color change we're talking about there. So new substance. So physical changes can be undone. No new substances are created, and then chemical changes are always creating a new substance.
Yep.
Questions, comments, concerns, Mr. Rhodes?
Ask him in class.
All right. See you guys then.